very important parameter, that is electric field strength. Electrical field strength of troposphere of troposphere or surface wave propagation. Surface wave propagation. Okay. So electrical field strength of troposphere or surface wave propagation. Okay. So for line of sight, let us consider the earth is considered as flat. When will you consider the flat? If the length between the transmitting antenna and receiving antenna is less, then we'll consider that the earth is supposed to be flat. Okay. If you observe here the earth, how it will be? It looks flat. But if you go very high into the space, then if you observe the earth, then the earth will be in curvature. Okay, so let us consider a flat earth. Flat earth means the distance between transmitting antenna and receiving antenna is less. Okay, so here we are going to design the electrical field strength, or we are going to derive the electrical field strength of troposphere. So what are the two modes for a signal to come from transmitter to receiver using troposphere? There are two paths. One is direct path and the other one is indirect path. Okay, so now first let me draw this diagram. Let me draw this diagram. Okay, so coming to the diagram, there are two parts. Let us consider this is my earth surface. Let us consider this is my earth surface. This is my earth surface. Let us consider this is my height of the transmitting antenna. This is my height of the transmitting antenna. Okay, so this is HT. HT stands for height of transmitting antenna. Okay. And this is my height of the receiving antenna. So this is HR. This is HR. Okay. So this is HR and this is H. Okay. There are two paths to come to the earth surface. There are two paths. So HR indicates the height of receiving antenna. Okay. So there are two paths. Okay. Let us draw the first path. So let us draw the first path. This is my first path. That is direct path. That is my direct path. Okay. So if you observe here, I make this angle like this. Okay. So let us consider this one. Okay. So this is the direct path. Okay. Call it as direct path. That is T. What is the second path? It is indirect path. It comes to the earth surface, touches the earth surface, and reflect back and comes to the sea. Okay. So this is D2. This is D2. Okay. So if we observe here, we extend the same replica here. We extend the same replica. This is nothing but again HT. This is nothing but our again HT. And here to here it is also, this is also HR. Okay. So we extend this also like this and close this and close this and close this. Okay. So this side the distance it is HR. This side the distance it is HR. Okay. So this is the brief structure regarding electrical field strength of troposphere. Okay. So here I am calling this as T dash. I am calling this as A, B, and this is M dash and R dash. M dash and R dash. So this is the diagram. Okay, now let T is the electrical field. E is the electric field of, so this is my direct ray. This is direct ray, and this one is due to this indirect ray. Due to this indirect ray. Okay. So D1 is direct ray, and D2 is indirect. Let E is the electrical field of direct. Field of direct. Okay, so from triangle, let us take this first triangle. So this triangle, T dash, R dash, M dash. From triangle, T dash, R dash, M dash. Okay. So what is the expression for D1? This D1 is hypotenuse. Okay. So D1 is equal to root of. What is the adjacent side? This total height is HD. Okay. So what about this height here? It is nothing but from here to here the height is HD minus HR. HD minus HR. Okay. So HD minus HR. HD minus HR whole square plus, let us consider the separation distance between the transmitting antenna and receiving antenna is D. Let us consider the separation distance between the transmitting antenna and receiving antenna is D. So D1 is equal to HD minus HR whole square plus B square. Okay. So if you write D1 is equal to, you write, if I take D square as common, so it is 1 plus HT minus HR by D whole square. Okay. The same thing I can write it as D1 is equal to D into 1 plus HT minus HR by D whole square into 1 by 2. Okay. So if D is very, very far greater than HT minus HR, what is this HT? HT is height of transmitting antenna. What is this HR? Height of receiving antenna. What is this D? D is separation distance between transmitting antenna and receiving antenna. So if D is very, very this one. So if I consider this equation as 1 plus X whole power 1 by. So since if D is very, very high when greater than to HT, so here the value of X is less than 1. So what is the expansion for this? X power 1 by 2 when the value of X is less than 1, its value is equal to 1 plus X by 2. So this can be written as, so D1 is equal to D into 1 plus, what is the value of X? X value is HT minus HR by D whole square into 1 by 2. So this is the value of D1. Okay, so this is the value of D1. So finally, what is the value of D1? D1 is equal to, so if I multiply with this one, D to 1 plus HT minus HR whole square by 2D. Okay. So if I multiply this, D plus HT minus HR whole square by HT minus HR whole square by 2D. Okay. So HT minus HR whole square by 2D. So D square, TD will get cancel, will have 2D. Okay, so this is the expression for D1. This is the expression for D1. Similarly, if we consider the other triangle, see the diagram. If we consider the triangle T dash BA, T dash T dash AB, we consider the other triangle T dash A B. Okay. So the now for T2, you are writing the expression for D2. Okay, so D2 means up to here, this distance. This distance is same as this distance. Okay, so D2 means this D2 is nothing but square of this side and this side. Okay, so what is this side? This side is D. What is this side? From here to here it is HT, and from here this is HT plus HR. The total distance is HT minus HR plus HR. Okay, so HT plus HR, sorry, it is HT plus HR. Okay, so we can write it as D2 is equal to, so root of B square plus HT plus HR whole square. Okay, the same thing if we substitute here and D2 will get D plus HD plus HR whole square by 2D. Okay. So this is the expression for D2. Okay. So this is the expression for D1. The expression for D1. Okay. So what is the total path difference? D1 signal will reach the receiver fast when compared to D2. Okay, so D2 have to travel a little bit distance now. Okay, so there will be path difference. Okay, so the path difference is equal to D2 minus. So, so if I substitute here, D2, you know the value of D2, you know the value of DT. Okay, we get the 2 4 HT by 2D plus 2 HT HR by 2. So that is equal to path difference. Path difference is equal to 4 HT HR by 2D. Okay, so this is path difference. Okay, so path difference expressed in wavelength. Path difference alpha x in terms of, okay, so path difference expressed in path. What is the relationship between path difference and phase difference? 2 pi times of phase difference is equal to phase difference is equal to 2 pi times of path difference. 2 pi times of path difference. Okay, so therefore the phase difference, therefore the phase difference, sorry, the phase difference alpha is equal to 2 pi by lambda times. Okay, so I am expressing in terms of lambda also. So 2 pi times, generally the relationship is 2 pi by phase difference of 2 pi times of path difference. Okay, so if I am expressing lambda, it is 2 pi by lambda into path difference. 2 pi by lambda into path difference. Therefore, alpha, the phase difference due to the path difference, it is 2 pi by lambda into, what is the path difference? It is 4 into HT HR by 2. 2 get cancel. So it is, what is the value of alpha? Alpha is equal to 4 pi HT HR by lambda. 4 pi HT HR by lambda t. So 4 pi HT HR by lambda t. So this is phase difference. This is phase difference alpha. Okay, so this is the value of phase difference. Okay, so one is due to path difference, and the other one is whenever the signal touches the earth surface. Okay, there is some 180 degrees phase shift. Okay, whenever it touches the earth surface, along with path difference, there is another phase difference due to touching the earth surface. Okay, so the total phase difference, the total phase difference, the total phase difference, the total phase difference theta is equal to alpha plus beta, where what is this alpha? Alpha is phase difference due to, alpha is phase difference due to path difference. Alpha is phase difference due to path difference, and beta is phase difference. Beta is equal to 180 degrees. That is phase difference due to reflection from earth surface. That is, the phase difference is due to reflection from earth surface. Reflection from earth surface. Okay. So therefore, the resultant electrical field, the resultant electric field, the resultant electrical field at a receiver, at a receiver is ER is equal to, resultant is equal to E naught plus K into E naught into e to the power of minus J theta. Okay, so that is E naught, if I take the 1 plus K e power minus J theta. So it is E naught into 1 plus K cos theta plus, sorry, minus J sin theta. Okay. So ER is equal to E naught into 1 plus K cos theta minus Kj sin theta. Kj sin theta minus Kj sin theta. So mod of ER, and the value of mod of ER, that is E naught into root of, what is the real part here? 1 plus K cos theta whole square plus K square sin square theta plus K square sin square theta. So here mod ER is equal to mod ER equal to E naught into, if I expand this. Okay, so what is the expansion for 1 plus K cos theta? It is 1 plus K square cos square theta plus 2K cos theta plus K square sin square theta. Okay, so is equal to E naught, if I take common, 1 plus K square, if I take K square cos square theta, K square cos square theta is there. So cos square theta plus sin square theta is equal to 1. That is cos square theta plus sin square theta plus 2K cos theta. Okay. So sin square theta plus cos square theta is equal to 1. Okay. So therefore, ER, the resultant electric field ER is equal to E naught into root of 1 plus K square plus 2K cos theta. 2K cos theta. So if we assume that Earth is perfect, Earth is perfect, then what is this K conductor? The K is equal to 1. Okay. So therefore, mod ER is equal to E naught into root of 1 plus 1, we get 2 plus 2 cos theta. Okay. So mod ER is equal to E naught into root of 2 plus 2 cos theta can be written as 2 cos square theta by 2 minus 1. 2 cos square theta by 2 minus 1. Okay. So therefore, mod ER is equal to E naught into root of 4 cos square theta by 2. Therefore, mod ER is equal to 2 E naught cos theta by 2. Okay. So we know that the total phase shift of theta is equal to alpha plus beta. This implies theta by 2 is equal to alpha by 2 plus beta by 2. That is alpha by 2 plus, what is the value of beta? Beta is 180 degrees. 180 by, so that is alpha by 2 plus 90 degrees. Therefore, mod ER is equal to 2 E naught into cos of alpha by 2 plus 90 degrees. So it is 2 E naught into sine alpha by 2. So this is mod ER is equal to, what is the value of mod ER? 2 E naught into sine alpha by 2. Okay, so we know that what is the value of alpha? Alpha is equal to, what is the value of alpha? So this is the value of alpha. Alpha is equal to 4 pi ht hr by lambda. Okay, so substitute here. We know that the value of alpha is equal to 4 pi ht hr by lambda t. Therefore, so mod er is equal to 2 e naught into sine of 4 pi ht hr by lambda t. Okay. So if you assume that the d is far, far greater than ht hr. Okay. So what is this d? D is the separation distance between transmitting antenna and receiving antenna. For example, if the separation distance between transmitting antenna and receiving antenna is 100 kilometers, and how will be the height of the transmitting antenna and receiving antenna? Height of the transmitting antenna is maximum, for example, 500 meters, receiving antenna is 200 meters. In that case, we can neglect. So, sin theta is equal to theta when theta is small. When theta is small. Okay. So, similarly, since d is far, far greater than hd and hr, this value will become 0. So, sin of 4 pi hd hr by lambda d is approximately equal to 4 pi hd hr by lambda d, since the value is less. Okay, so sin theta will becomes theta when the theta is small. Okay, then the theta is small. Therefore, what is the value of ER? ER is equal to 2 E naught into 4 pi hd hr by 2 lambda d. 2 get cancel. Okay, so therefore, what is the value of mod ER? Mod ER is equal to E naught into 4 pi hd hr by lambda d. Okay, so next, if F represents the F, F is the field strength of direct ray, that is free space field strength, free space field strength at unit distance, at unit distance, then E naught is equal to EF by D. Therefore, F is equal to, where F is 7 root P, where this P is effective power radiated, in watts. Okay. So now what is the value of E naught? E naught is equal to 7 root P by D. E naught is equal to 7 root P by D. Okay, now in the place of E naught, simply substitute this value. Therefore, ER is equal to the resultant electrical field. ER is equal to 4 pi into 7 root P divided by D into HD HR by lambda. HD HR by lambda. Okay, so therefore, I am simply substitute 4 into, what is the value of pi? 3.17 into 7 into 4 P into HD into HR by and by lambda d square. Okay, so therefore, mod DR equal to 87.92 root P into HD HR by lambda d square. Okay, so this is approximately, it is equal to, therefore, yeah, ER is equal to 88 root P HD HR by lambda d square. So this is the very, very important equation. Total electrical field at the receiving antenna using space wave or propagation, line of sight propagation. So here, what is this root P? Root P is effective power radiated, effective power radiated watts. And what is this HD? HD is height of transmitting antenna. What is this HR? Height of receiving end. What is this D? Separation distance between transmitting and receiving end. D is separation distance between transmitting antenna and receiving end. So this is the final total electrical field strength. Okay, so electrical field strength of troposphere or space wave propagation. Space wave propagation.